Today, this last talk, we're going to talk about copy-paste. Everyone likes copy-paste, right? So, who haven't been yesterday to my presentation? Have anyone? Did you go to my presentation yesterday? No? You missed a lot. So, okay. So I do performance and security at Cloudflare. I'm passionate about cryptography. I also enjoy low-level programming. So that's what I do. But today we're going to talk about copy-paste, and today we're going to talk about blocking copy-paste, and this is mostly related to blocking copy-pasting passwords in web applications. That's why we'll talk about passwords first. So passwords, right? Passwords have a long history. So they're probably one of the oldest pillars of authentication out there. So, for example, in Roman Empire, they didn't call them passwords, they called them watchwords. And when the watch shift changed, they had a word where a new shift authenticated itself to the old shift, so they know that the change is genuine. And Romans had a very sophisticated system, so they never reused the watchword, so they were rotated daily for each shift. And even from modern security standpoint, they had a very sophisticated system. And even today, passwords authentication probably takes 75% of all authentication on the web. And some say no, like passwords are old school, we have modern new technologies now, but even with modern technologies, we still use passwords. Like two-factor authentication, one factor is always a password. You use a security key to authenticate yourself, you authenticate with the key with the password. So password will likely stay. And because passwords are so simple and efficient, they're also an attractive target for attackers. So what are the most common password attacks now? You can break them down to 3 categories, like big categories, brute force attacks, you can have dictionary attacks, and you can have services account and hijacks or leaks. So what is a brute force attacks? It's simple. A potential attacker tries every possible combination out there until they kind of guess your password. Simple and efficient, so they try all the variants. It's actually not efficient, but it's a simple attack. Dictionary attack is it's not what you see here. It's when the attacker tries to actually improve the brute force attack and to exploit the fact that humans do not come up with passwords which are random sequences of characters. They usually come up with some words, and they come up with a list of most commonly used words. Unlike some people, which I mentioned later, they don't check it manually. They write a small program, like a login script, which takes a list on the input and tries every password from that list until it succeeds. And finally, services account hijack or leaks can be broken down to client-side ones, where you, for example, get a phishing email asking, someone's pretending like support from the service you use, and they ask you for a password. Insecure or fake pages, so either attackers create fake pages which look like genuine ones, and you type in your password and you leak it, or some sites do not know that you should provide login forms over HTTPS only, and they miss the fact. Even Yandex at some point did it, and so that you can leak your password. And there is also social engineering aspect. They can call you, pretending to be from the company or service you use. There is also server side. Like every service out there, sooner or later leaks some kind of database, and that database can contain your password. There is cold vulnerabilities. So attackers actually break like WordPress blogs or many other things and get the passwords themselves. And there is also server-side social engineering, when you call like enterprise company pretending to be a CEO of their biggest client, and get them to do whatever they shouldn't, pretending to be very angry. Okay, so based on that, passwords today have quite complex requirements. So they have to be long to protect yourself from brute force attacks. They should be random looking like. So to protect you from dictionary attacks, they should be hard to guess. I don't know, like the most common thing people put in password is their birthday, which is kind of public information. So you shouldn't do that. And most importantly, they should never be reused for end websites, because if the attacker will go for the weakest link. If you reuse your password on your main Gmail account and on local utility bill provider, probably the attacker will break the utility bill provider and immediately will try that password on the Gmail attack. So like they broke your weak account and they broke your old account, so never use passwords. But the result of these requirements is that long passwords are hard to remember. Random-looking passwords are hard to remember. Hard-to-guess passwords are also hard to remember. And never used for end websites is n times hard to remember, because now we have many passwords. And like the requirements keep increasing. Like the more sophisticated attacks come out, and now you have more and more different requirements you should implement, right? Okay, so who reads RFCs here? Who read at least one RFC? Yeah. Huh? Any? Okay. So RFCs are basically internet standards, right? We all use the internet, we should know standards. This is an interesting extract from RFC 7616, which describes HTTP digest authentication, which is like password authentication over HTTP. And digest authentication should be used only with passwords that have reasonable amount of entropy, 128-bit or more. Such passwords typically cannot be memorized by humans, but can be used for automated web service. So even the internet standard tells us that modern password cannot be easily remembered by humans. But this is digest authentication. Most websites just use basic authentication, which is even less secure, and we use these two every day on the web. So like, what to do, right? So we need to, there is a way. There is a modern way to do it with the password manager. So what is a password manager? Remember, you never use your password, so you have complex and all the passwords for all the web services. You use one for each web service. Then you take a database, which in password managers they call it a vault. You put your passwords in the database. Then you come up with one secure master password. The password manager will derive an encryption key from your password and encrypt your database. Now we get many advantages. So you have to remember only one password now, right? You have to come up with a strong password, but it's only one password. And then your service passwords can be as complex as possible, as required, right? So because you don't have to remember your service passwords, computers are much better at remembering passwords than humans. They can be very complex. Your passwords, service password can be totally random because you don't have to remember them. And they're very easy and simple to use, password managers. So happy end. Thank you for coming. See you next year, right? No, there is always a second part. Do you know who this is? Yes? Who is it? It's probably your project manager or your systems architect or like a senior developer, which tells, oh, we need to implement security on our website, so we should make our users secure, so we should block password pasting. So the ultimate requirement for password manager, because you store the password elsewhere, you need to copy it and paste it into your website, right? And surprisingly, many websites started blocking that functionality. And so this is a link to a quite old Troy Hunt blog post. You know Troy Hunt? He's a famous security researcher from Australia. So he actually investigated that fact. He tried to he found many popular websites which do that. He tried to contact their support and asked for the reasoning why do they do that. And surprisingly, he didn't find any valid one, but here are the categories he found out. So the first, most technically sane reason is clipboard security concerns. So the support reply was, we encourage users not to paste password but type it in, because if they have malware running on their computer, they can have access to clipboard and steal the password. Well, to be honest, these, again, this is that Darth Sidious systems architect probably doesn't have a system development background, and he doesn't know the operating system security model, where if you have a malware which can steal passwords from your clipboard, probably that malware can intercept keystrokes. So whether you type it or paste it, doesn't matter. So it's a kind of shit show argument, right? Like false security. The other type, like other popular response, that they somehow they protect themselves from brute force or dictionary attack protection. So somehow that Darth Sidious architect imagines that attackers actually have a list of passwords and they like copy paste it manually and try like this, like they do it the whole day and they're attacking their service, right? And the weirdest thing is like some people just reply it's our compliance requirements, but the immediate follow-up question, because all of these requirements are public, like can you send me a link to which ones, and nobody ever responded which ones, because there are no compliance requirements like that, as far as I know. If you know, just let me know, let Troy Hunt know. We're hunting for these requirements for 5 years now. And the stupidest thing you can get, because it's our procedure, it's for your security, some just say that it's the default browser behavior, it's nothing to do with their web application. Or like, because we can, it's a typical developer response. There is a rebel movement to actually counteract these evil websites, right? And there is some things you can do now. So the first one, if you use Firefox, you can set this config value. To make this not very boring, I'll even show you quickly how it works. So we have a fresh Ubuntu machine I just installed today or yesterday. So you have the, I have this website which kind of emulates how web application block password paste. So I have this fake password manager where I store my super secure password. So yeah, and we can try to copy paste it. So here I can paste, right? So here it pastes, so I can delete it. Now I try to paste here. So it actually emulates two of the most popular way of password blocking. So yeah, and I can't paste it here. But if I go to settings, about config, let me know if it happened. Yeah, and here be dragons. So like not everyone, and yeah, like I'm okay to see dragons. Show me the dragons. You find the settings, clipboard events. By default, it's enabled. I just send it to disable. The setting takes place immediately, and now I can paste the password here, right? Easy. So what I did now, so because password blocking is usually implemented by evil JavaScript, I just disable the browser not to emit these events, so that JavaScript doesn't work anymore. I'll set it immediately to true back and see if it doesn't work again. Yeah. Yep. So. This approach has some properties, right? Like what it does is basically disables emitting on copy and cut and paste events. So these two most popular methods do not work anymore. There is no external dependencies. It's easy, although you may see dragons. Although it's not reliable, right? So like this is like a most straightforward to do the task, but some developers, like JavaScript devs, are really, really stubborn, and they like overcome this using a different events, like, or they measure the timing between the characters appear on the input field, and they detected you paste password instead of you typing it in. So It's not very reliable. It's not portable. It's only Firefox. If you don't like Firefox, you can't use it. And it can break other functionality, right? So like these events may be useful for other applications. We have so many like complex reactive applications nowadays, so just disabling this whole set of events can just break a lot of stuff for you. So it's, in Russian time is стрелять с пушки по воробьям, да? Or English version is cracking a nut with a sledgehammer. There is another type. There is some kind of browser extensions. I can show you even. I think I have one. So there are, like both Mozilla and Chrome, they have a web store. There you can find third-party browser extensions which can restore paste. So let's double check we cannot paste our password here. So I can paste it here. I can't paste it here, right? So here I have a browser extension installed called Don't Fuck with Paste. It's actually the most popular one. You kind of enable it for this specific website. I think, yeah, so now it's enabled, and I think I can paste password now, right? So let's check. Let's disable it again and check if I can't anymore. Okay, trying to paste. Yeah, I can't do it anymore. So these are browser extensions. Where is my window? Okay, so browser extensions. They basically do it in two ways. The first one we just saw is like a third-party browser extension. They inject just more JavaScript, which tries to counteract the evil JavaScript, which disables password blocking. They're usually third-party. They don't basically have access to your passwords, and they just try to unblock the blocking paste functionality. There is also like plugins which just manipulate document object model directly to inject password values into the password fields. These are usually implemented by password managers themselves because they have access to the password. When the page loads, they just pre-fill the passwords for you, which is quite handy. The pros are they're easy to install. Just go to the web store for your browser and pick one. Usually require zero configuration, although as we saw, I need to actually enable it for particular websites. There are downsides. They're, again, not reliable. They may not capture all blocking techniques. They're not portable, usually Firefox or Chrome only. And so this don't fuck with space implemented for both, but some are not. And what do you do for Safari or Windows Explorer? And they also can break other functionality. So they mess with your document object model, and they can like go sideways. And for me specifically, there is also a big, very big downside. I don't want to use third-party extensions. Is security considerations. So when you install such extensions, you usually get this window that what it can do. And actually, all these extensions can read and change all your data on your websites you visit. And remember, these third-party extensions, third-party code, has access to manipulate your document object model. And the processing happens after TLS termination. So the green lock will not save you there. So like they can inject into your page whatever they want. Also, they run in the browser, which by default, by design, has full network access. There is nothing preventing it from just grabbing all your passwords or browsing history and download it to some kind of weird Chinese server or do whatever like manipulations they want to your web page. It's quite scary. Yeah, what could go wrong using these extensions? Well, but like I'm a systems engineer, and this is like a web application problem, but I will just like pissed off that like some third-party application dictates me what I can do and cannot do on my machine, right? And I think, can an operating system help me with that? And it seems there is a hope. There is a new hope. Maybe it can. So let's go back to how password blocking works. So basically, you have a web application, you have your users. Users are trying either to paste or type in your passwords, and the web application implements some kind of a filter in JavaScript to block paste, but to allow types. They need to allow users typing the passwords, otherwise users cannot log in, right? And all these techniques we described before, they somehow try to disable this filter, right? So what if we go with a different approach? Instead of trying to mess with the application, let's just give it what it wants. They want us to type in the password, let's just type it in. But instead of typing it ourselves, let's paste our password to the operating system and ask the operating system to type it in. So here, the type operation will be allowed by the filter, because filter, by design, needs to allow you typing in. So I wrote a small tool called passkb, just for that purpose. So you have a web application, you're the user. What you do is, and my tool is just a simple command line application written in Go. What you do is, instead of pasting your password directly into the web app, you paste your password into the tool, and on Linux, that tool will use a special device file dev input, and on Windows, it will call the Windows API send input function, and these two methods will just type in the password into the web application. Here is the demo. Oh, it went to sleep. This is my temporary machine, so my password is very easy. Don't reuse it. Okay, so again, let's double check we can and cannot paste, so no extensions. Let's type in here, copy it and try to paste. Yeah, paste is blocked now. So yeah, we have the terminal. I'll cheat a bit, I'll just reuse the history to find the command. So this is a simple Go application. You can easily use it go get to get it from GitHub and compile it from source. It went fast because I already did it, but like it will be some delay and it will download and compile it. So if you know Go, you'll have a binary in your Go bin directory. On Linux, it's a bit complicated because by default, if you try to run it, you'll get an error message because it needs to use a special device file, and by default, that special device file is owned by root and only allows you to have root access. So what we'll do here, we'll change the permissions. I'll explain it later on that device file to my user. Sorry. And now we can start the tool. So the tool just asks you for a password. So what you do, you take a password from your password manager, you copy paste it to the tool, you press enter, and you have 5 seconds to put the cursor here, and you just wait. It's configurable, actually. And nothing happens. The demo Go didn't. Did I not press the enter? I think I didn't press the enter. Ah, right, wait. I know what's wrong. Because it's Linux. In Linux, to paste into console, you have to press Ctrl-Shift-V. Okay, let's try again. Shift-V. Enter. And type in. Type in, type in. It worked all the time. Oh, here it is. Yeah, so I even implemented a small delay to protect from these weird developers that, like, if they measure the time, then the characters appear. I measured that the typical human, if you type quickly, you have 300 milliseconds between the characters. So this is how it's implemented in the application. Yep, so there is some Linux specifics, as you saw. Unfortunately, Linux passkeyb uses this special device file, and the process requires read-write access to the device file, but on most Linux distributions, this file is owned by root with this access mask, so only root can write there. What you can do is basically, not recommended way is just run my tool as a super user. You kind of violate the least privilege principle. What we did now is basically I changed the owner of the device file to myself and run the software is for myself. It's good if you're the only human user of the system, basically, but if you have several users and all of them want to do that, that's probably not a good way. The best is to create a dedicated group, change the access mask to 660, and add all the users which want to use that functionality to that group. And basically, remember that device file system is a temporary file system, so changes do not persist on reboot, so you have to do these steps via udev rule or some kind of startup script. On Windows, it seems it works as is, so like at least like you can paste passwords for yourself into your browsing session. The advantages, it's cross-platform, browser independent, and even beyond browser. So even if you have a stupid fat UI application which also blocks pasting, you can still use my tool. It has no access to your browsing data. It's enforced by the operating system. It's a different process. It can only type stuff. It has no network access by default. It has no code for network access. And you can further down constrain it, put it in a container, and allow it only to talk to that special device file. So you're safe from here. It's a separate constrained process, and it follows the Unix do one thing philosophy. So there is no fancy functionality which expands the attack surface. So it's written in Go, so it's quite hard to exploit, I think, I hope. And it has no network access. Simple and reliable. There is no settings, there is no state, no heuristics, like no trying to guess how the implementers of the web application implemented the block in the first place, because we produce the input for them in the form they want initially. And it cannot be detected or blocked, right? Because the same way this tool has not access to the browser doesn't have access to this tool. There are some downsides, of course. It still doesn't work on macOS. I know there is an API for that, but I have the least experience with developing in macOS. If somebody wants to help, please do. It should be straightforward. Unfortunately, it does not work on mobile devices, but again, it probably can. You can design a similar app for mobile devices, because mobile devices have virtual keyboards, therefore they have the API to type in stuff. And usability, right? You run a terminal alongside the browsing session. You need to a little bit mess with your Linux configuration, at least during the initial setup, and you need to switch Windows to paste the password. But again, I don't think this is too much for the security gains we get. So what can you do? Who doesn't here use a password manager? Doesn't. You doesn't. It doesn't. Nobody. Start using a password manager. Like, I work for Cloudflare, we process a lot of internet traffic. Internet is freakingly hostile these days. Start using a password. Password manager is the state of the art you can do these days. If you're a web developer, reconsider messing with paste. If you get the requirement, counter it. If you think of the requirement yourself, just don't do it. Please don't do it. Use my tool. Please provide feedback if you want. Make it work on Mac if you can. And basically, and finally, this presentation is not about the tool. What I wanted here to show is the concept that blocking password paste is useless and can always be bypassed by your operating system. So spread the word, show this presentation, and let's just convince people to stop doing that, because it doesn't make any sense anymore. We win, right? We who want to paste passwords, we win now. We can always bypass any web JavaScript technique out there. Yeah. Here are some useful links. So this is the original Troy Hunt blog post. I encourage you to read it. He is a very interesting author. He writes in a very humoristic way. Just not to say we are all, like we security researchers all make it up. This is the official requirement from a UK government cybersecurity center not to block paste. So anyone, at least in the UK, who says it's required by a compliance just lies, because the government tells you not to, and you can't have compliance which is conflicting with the government, right? Just to give credit, that website, test website I used to show you the blog post comes from this blog post. Just to not to discredit the author, she was also very frustrated with websites blocking paste, so she wrote about it. She tried to learn how it's been done, and she wrote this test case to show how it's done. But the author of the blog post is encouraging not to block paste. And the link to my tool. And finally, if you block paste, we will find you. Thank you.